Okay, so this is a video for chapter 12 where we discuss the short run cost curves. I'm all set and ready to go with 5 different fine tip markers. So this video will explain the 4 major cost curves that we use again and again in this part of the course. The theory behind them, we'll talk about the definition of each of these, and then look what they look like in the graph. So the first one that we think of is variable cost, VC, variable cost. This is all the items that are equal to 0 if you don't produce anything, and then increase as quantity increases. So if we're thinking of something like an Uber driver, for example, this would be gasoline, right? The more rides they give, the more they have to spend. Gasoline would be a variable cost. We use variable cost in our per unit graph as average variable cost, which is just variable cost divided by quantity. And variable cost divided by quantity gives us average variable cost. All A's are averages in our abbreviations this chapter, and all averages mean divide by quantity. Kind of the twin to average variable cost is average fixed cost, which comes from fixed cost. Fixed cost never changes as quantity increases, and it's present even if quantity is 0. So in the context of an Uber driver, this would be something like their vehicle. They had to pay for it even if they didn't give anyone any rides. Or if they paid Uber to get a background check, they had to pay for that background check even if they didn't give anyone any rides. Fixed cost gives us average fixed cost, which is just fixed cost divided by quantity. Our third major cost curve is a combination of those two. It's TC, total cost. It's just the sum of fixed cost plus variable cost. Right? So total cost doesn't care whether we're talking about gasoline or background checks. And it gives us ATC, average total cost, which is total cost divided by quantity. Another way of thinking of average total cost is it's the sum of average fixed cost plus average variable cost, which you could see if you just divided this whole equation right here by quantity, you would end up with this equation right here. Okay? And you know that in chapter 13 and 14, we use average total cost all the time to tell us about the level of profitability of a firm. Okay, and our final cost curve is the one that we use the most often, marginal cost, MC. Economists love to think marginally. This tells us the change in total cost divided by the change in output, the additional cost that every unit we produce creates. And marginal cost we use all the time. In our golden rule, we set it equal to marginal revenue, and it tells us the profit maximizing level of output for an individual, whether that's a monopolist or a perfectly competitive firm. So we use it constantly. Okay, so now that we have these 4 definitions, average variable cost, average fixed cost, average total cost, and marginal cost, we're going to talk about what do they look like in the graph. You can graph each of these 4 curves in quantity and price space. So quantity, if we're talking about our Uber driver, this is the number of rides they give. And then all of our costs are in dollars per unit. So the cost per ride. Okay? Average variable cost, our first cost curve, is shaped like a U. So you could draw a big U anywhere in your graph. Average variable cost is U-shaped for 2 reasons. And this is one of the key parts for understanding the theory of the cost curves. So I'm going to write it out for you right on here. Average variable cost, average total cost, marginal cost are all U-shaped. And as part of that U, they initially fall due to specialization, and then they eventually rise. But the initial part where these costs are falling, in the beginning, when you first start driving for Uber, you've spent all this money on your car. You haven't driven very much though. So you're spending a lot on gasoline at the beginning, and you're not getting many extra rides output because you're just getting to know the city, maybe. You haven't yet specialized in a part of the city that you know really well, which is going to make your marginal productivity increase at the beginning. As you move from giving 2 rides to 3 rides to 4 rides, you're getting good at what you're doing. The equivalent in our factory was adding additional units of labor, right? The first person hired had to do everything themselves, but as new units of labor got hired, they began to specialize in the activity they were good at, which made productivity increase in the beginning. And all of these are thinking about changes in quantity. So in the beginning, the quantity output is rising, which is drawing all of these costs down because quantity is on the denominator of all of these cost curves. Okay? But they eventually rise because of diminishing marginal product of labor, right? So our story about in the short run, when capital is fixed, remember these are all short run cost curves, and the short run means that at least one input is fixed. So when the amount of cars you have is fixed, as you add more and more workers, they just get in each other's way, or the amount of hours you have in the day are fixed. As you drive more and more, eventually you get tired, you run out of areas of the city to learn, and the benefits from specializing fall. Something's happening that eventually makes, in any industry you can think of, productivity fall. If an input is fixed and you add more and more labor, that labor's productivity will eventually fall. Okay? And because quantity is on the bottom of all of these cost curves, when quantity falls, the costs start to balloon upwards. Right? So average variable cost also has quantity on the bottom. As quantity begins to fall, with productivity falling, that balloons the whole thing up. Same for average total cost as well. Okay. So that is one of the key facts about our cost curves, that all 3 of those are U-shaped. The other key fact has to do with average fixed cost. It's just going to constantly fall. Think about our definition of average fixed cost. Fixed cost divided by a quantity. Fixed costs on the top are never changing. So as the quantity increases and we move along the x-axis, we're dividing by something bigger and bigger. You're spreading out the cost of that vehicle across a larger and larger quantity of output. So the more rides you give, the lower your fixed cost. Average fixed cost is always going to be asymptotically approaching 0 for those math specialists among you. And the reason why I dashed it is because, as you saw in chapter 14 and 15, we hardly ever use it, right? It's kind of implicitly in our graph based on the difference between average variable and average total cost, which we'll talk about in a second. But we don't use it on its own to decide anything in chapter 13 and 14, so it's less important, which is why I dashed it. Now, the next important concept from our cost curves is that average total cost is equal to the sum of average variable and average fixed. That's just part of our definition. But because of that definition, it approaches average variable cost as average fixed cost falls to 0. Average total cost is going to be getting closer and closer to average variable cost as the average fixed cost is going away, right? So on our graph, if average total cost is at every quantity the vertical sum of average fixed plus average variable, then it's going to be right there. And here, it's going to be this number plus that number, so it's getting closer. Getting even closer. Getting even closer. Getting even closer. Getting even closer, right? This is where the idea of the crooked smile comes into play. It is a U, right? Because it is driven by all of the diminishing marginal productivity story over here and gains to specialization story over here. But it's also getting closer and closer to average variable as average fixed falls to nothing, right? So it's affected by the fixed cost story and the variable cost diminishing marginal productivity story. It's a combination of the two. The last of our cost curves, and the most important, the one we use most frequently, is marginal cost. And there's one additional fact. So these are like on the last problem set, I believe there was a question, actually it was on problem set 5. How are the curves related to each other? And what's the theory behind their shape? A complete answer to that question includes why 3 of them are U's, why one of them is constantly falling, and why one of them is approaching the other. And lastly, that marginal cost hits average variable and average total at their minimums. And the way that I explained that in class was the GPA example. Marginal variables are the new variables, like your fall semester grades. Average are the average of all the semesters, your overall GPA. And when your new grades are above your GPA, they are bringing your GPA up. So your GPA is rising. When your new grades are below your GPA, they're bringing your GPA down. So it's falling. So that's just a characteristic of marginal and average variables in general. The way we would draw that on our graph is we would look for the minimum of these, something like that. And marginal cost is a U. It's more like a Nike swoosh though, because it's very quickly impacted by diminishing marginal productivity. So it falls initially, but then begins to rise steeply. And that U part of it is like somewhat theoretically important, but we don't know where it's going to happen. You could draw it there, you could draw the U happening here. It does not really matter where you draw the beginning of that Nike swoosh. We would need some data to know, exactly how high the marginal cost was relative to the fixed and et cetera and all of that. It would look very different for all firms. What's important is that it has a period where specialization is bringing the cost per unit down, and the marginal is below the average total and average variable, so they're falling. But then eventually diminishing marginal productivity affects it, and marginal cost begins to rise. And this is usually the space in our marginal cost curve that we think firms will operate in, right? They hardly ever choose to operate way over here unless their marginal revenue is incredibly low. So this acts more like a supply curve, which your book talks about, because if you plug in a price over here, marginal cost is how firms decide how much to produce. So the marginal cost curve will spit out a quantity supplied over here. Right, okay, so what we know about it though is that it's hitting these two at its minimum, it's U-shaped, but quickly affected by diminishing marginal productivity, so we call it a Nike swoosh. Okay, so hopefully that clarifies the cost curves. You should practice drawing them. You should know A through D about their shape and the theory behind their relationship. Apologize for my handwriting, but I hope this is still useful. And you should practice drawing them so that you can do this relatively quickly. So for any industry, let's say we're talking about t-shirts, you should be able to describe why the cost per t-shirt is initially falling as you add workers and produce additional t-shirts because they're producing relatively quickly additional quantities as they specialize. But eventually diminishing marginal productivity kicks in and the cost per t-shirt is rising. And then there is average total cost, which reflects all fixed and variable cost, hits this one at its minimum, and average variable cost, which is getting closer and closer to average total as its friend on the bottom. Average fixed cost is just kind of floating away to nothing. Okay, hopefully that helps. Practice drawing them. Let me know in the review session later if you have any remaining questions. And good luck studying. Remember, these guys are very important that you understand them theoretically because they are key parts of our graph in chapter 13, 14, and 15.